So on our electric field practice sheet, we're doing the exact same thing, but we're not trying to do all the math. We're going to visualize by drawing out force vector arrows. I'm going to do one of the trickier ones for you. Let's not do the first, second, third. Let's do number 7 down here, okay? Here we have a positive source, and we're going to assume that A is twice as close as B. So what does the field look like? At point A, how do we test the field? We use what kind of test charge? A what? A positive test charge. So all I got to do is take my ruler, line it up with the center of the charge, line it up with point A, and then sketch in a little dotted line until I hit point A, and then make that line solid. Okay? And I'm going to make this line, I'm going to pick something arbitrary. How about 2 centimeters in length? Okay? 2 centimeters in length to represent the idea that this is a certain size force there. Okay? Now at point B, we still use what kind of test charge? You always want to use a what? A positive test charge. But we're going to say that B is twice as far away. Aha, what does that mean? The force is going to be what? 4 times smaller. If I made this line 2 centimeters, then this one should only be half a centimeter. It's 1/4 the strength, 1/4 the force there. Okay? So it's a little tiny midget arrow, which I had trouble drawing there. Let me zoom in. There you go. So I can draw that better. So this arrow is going to be 4 times smaller is the goal here. So maybe I want to label this 1/4 the force if this is 1F there, okay, to represent that idea. So this one's not hard. It's just trying to visualize what's going on, okay? So why don't we do one that is a little bit trickier? Why don't we do this one? This one's kind of cool, okay, right down here. So here we have point A, and it's the same distance between 2 negative charges. So you tell me, what would a negative source do to a positive test charge? It would attract. That's it. So from the center of each charge, we're going to draw an attractive field. And because it's equidistant between the 2 charges, we should draw the vectors different sizes or the same sizes? Same size, okay? So if I make this one, 2 centimeters, let's say, then I should make the other one 2 centimeters as well, right, with my ruler here. And then how do I get my resultant? Can you figure this out? This one's trying to pull this southwest. This one's trying to pull it southeast. So what's the net effect? It's just going to go straight what? South. Okay? But the way you want to sketch that is you want to form a parallelogram. Let me zoom in. What's a parallelogram? It's a quadrilateral shape where the opposite sides are parallel. So it'd be something like this, and then something like keeping it parallel, like that. And then it's always from where you start to where you end up. Okay? So the field here would just go straight south, like this. This is my force resultant. Okay? So if I have 2 negative sources, the net field would be straight down. Why? Because to find the net effect of multiple sources for fields, you add up each field individually, and then the resultant you can find by just adding them both up. So if it's equidistant from the 2, the force is the same. The westward pull and eastward pulls cancel out, and then the net south pull is what adds up. So this sucker will just get sucked straight south there, okay? Well, it looks like I whiffed because it went a little bit to the right. Theoretically, it should have just went straight south there. Okay? Lots of fun. So anyway, in the end, visualizing fields, it's actually not that hard. You can do it. That's what we want you to focus on for this unit.